Hey everyone, today I'll be running through the CoinFlip challenge using Ethers.js and hardhat. If you want to learn how to set that up, I have a video for that in the description. All right, let's jump into it. So this is a coin flipping game where you need to build up your winning streak by guessing the outcome of a coin flip. To complete this level, you need your psychic abilities to guess the correct outcome 10 times in a row. Okay, so let's have a look at this contract here. So we've got a consecutive wins variable here, a last hash, and some kind of big number factor. In the constructor, it sets the consecutive wins to 0, and then this is obviously the interesting function we want to have a look at here called flip. So flip will have a guess, which we give it, and it calculates a block value by getting the block number and subtracting it by 1, and then getting the block hash of that block number. And it verifies if the last hash, okay, so this is because if you were to do this constantly in the same, if you were to guess multiple times in with the same block value, it's going to revert back, so that's interesting. It then sets the last hash back to the block value that we just calculated, and then it does a coin flip to divide the block value by the factor, and then if the coin flip is equal to 1, then it's true, otherwise it's false, and if we guess correctly, it returns true, and it increases the consecutive wins. So I guess to win this entire contract, or this challenge, we need to get this consecutive wins variable to be 10. So the way that you solve this is not through any fancy means, but by actually deploying a secondary contract. So I'll show you what I mean by this. When you have another contract and it can calculate this and then call this contract as well, you can pre-compute what this value is going to be, and then you can just kind of work that out that way. So the way that we do this is, let's go ahead and grab this contract, and we're going to create a new file called coinflip.sol, paste it in, and you can see we've got the contract here now. And the way that we're going to solve this is actually by developing a second contract. So I'm going to post another contract here called attack coinflip. And we want to be able to interact with this contract. So the way that we do this is I'm going to set a new variable called coinflip, which is of type CoinFlip, so of type of this contract up here. And I'm going to create a constructor which passes in an address of the challenge. So when we deploy this, we can set it to look at the challenge contract that we're looking at. So then we can set CoinFlip is equal to a new instantiation of the challenge. Okay, so then once that's done, I'm going to create a new method called attack. It's not going to take any values, and it's public. And so basically what we're going to need to do is recreate this entire flip thing here. So let's have a look. We can get this block value here. So I'm going to copy this. And if you're doing this without importing safe math, you're going to run into a problem. You could just literally subtract it by 1, but they're just using safe math here. So we're going to run that sub 1 here, so we have the block value. Then this doesn't matter for us. This doesn't matter for us. This is what's important for us, which is the coin flip. So let's grab that and get the coin flip. And we're also going to get the factor, because that's going to be important. I'm just going to save that as a global variable here. Okay, so then once we've done that, we have the side, which is calculated. And then once we have that side, which is a Boolean, we can use this to call the coin flip challenge. And again, the reason why this works is I'm going to call this contract in my transaction, and I'm going to call this method, and all this is all deterministic, because this will then call, you'll see it right here, when I run coinflip dot flip, I think, yep, with the guess of side. So this contract is then going to call this contract, which is going to compute the exact same stuff because the block hash, the block number is all going to be exactly the same because they're in the same transaction within the same block. So we do CoinFlip.flip, and that's it. So we essentially need to do this 10 times. Now, the reason that I'm not doing this like as in a for loop 10 times within this attack method is because up here, it's going to check that the block value is not the same as the last block value. So you need to do this in separate blocks, essentially. So that looks pretty good. Let's go ahead and make sure that we can compile this by running npx hardhat compile. Cool. Sub. Not visible after argument dependent lookup in uint256. What have I messed up here? Number 48. Yeah, that's mine. Oh, so what we need to do is make sure that we are using safe math. So that's just the one thing I missed to overwrite that type. So we can compile this now. This should work. There we go. So that's compiled successfully. And now let's start typing up our script. So I'm going to copy my template here and call this CoinFlip. And let's go ahead and get the contract address. So I think it's this one. And so the next thing that we're going to do is we've got our contract. We're going to need this to be CoinFlip. So this is our contract. And so we're going to do something different from anything else we've done before, is actually deploy another contract. And so the way that we're going to do that is by creating a contract factory. So again, this is a method that is built on top of Ethers.js by hardhat. So we await ethers.getContractFactory as opposed to getContractAt because we want to deploy a new one. And this is going to be called attack CoinFlip, which is the name of our contract. And we want this to be deployed by our own player, which is the signer. So once we've got this factory now, we then want to actually deploy this. So CoinFlip attack contract is equal to CoinFlip attack contract. Notice the capitalization here. And on this object, there is a deploy function. And we're just going to await for that to finish. So the deploy requires whatever the arguments are of the constructor. So as you can see, we have a argument of the challenge address. And so the challenge address is what we define in our contract address. All right, so we now have deployed our attack contract. We have our contract at the contract address. So all we need to do now is call that function 10 times. So let's just do a simple for loop here. That's going to run 10 times. And we're going to await the CoinFlip attack contract dot attack. No. Attack. Cool. And so what I'm going to do is, now that this is created, so I'm going to just do some logging and say that the attack contract is deployed at, and pass in our CoinFlip attack contract address. And after each run of this, I'm going to get the wins. So we're going to run CoinFlip, our contract, await contract dot consecutive wins, I believe the variable was called. And then that's going to return a big number. So then we can just go console.log current win count is wins.toString. Like that. And so this should all work. Let's have a look. So we're going to try and run CoinFlip.ts. And it's going to, so Bang. All right, cool. So we had the attack contract deployed at this address. We can see that the current win account was 1, and then we deployed it again and again and again and again. And if we have a look on the contract on our blockchain that we're running locally here, you can see that we are, calling the method, and then we're reading the value of consecutive wins. And so that goes on and on and on. So now that the current win count is set to 10, we should be able to submit this instance with, I don't know, it should be like 21 maybe. I'm going to get the nonce wrong as usual. Was it 24? All right, so we hit 24, submit the instance, and we get it correct. So cool. Hope you guys all understood that, and I'll see you in the next one.